Alright, so we're looking at this, we're starting on question 3 of C. I said yesterday we did part of C. So starting question number 3 of worksheet C. The first thing, as you notice, like I told you guys yesterday, start with the easy stuff. Start with the given. Right? Start with the given. In this case, we got 3 statements. Look for your given and write your reason for it. It's because it was given. So looking at question number 1, angle 1 is complementary to angle 4. Angle 2 is complementary to angle 3. Why is that true? Because it was given. Then I look at statement 2. RT bisects angle SRV. Given. And just like yesterday, I'm going to be writing my reasons right next to the box. And then for you guys, I drew little lines at the side. Lines for number 1, 2. So you guys have the space there. Okay, looking at question number 3, or statement 3, notice that comes from statement 2. So looking at statement 2, it says RT bisects SRV. What does bisect mean? It cuts in half. So one half equals the other half. So we have angle 3 is equal to angle 4. Like one half equals the other half. So we talk about bisecting, and then we say what bisecting does. So what's my reason? What was it? Definition of bisect. So for 3, we're going to say definition of bisect. Every time one of the statements is a rule, and the other statement is what the rule does, that's the definition of such rule. Okay, so we had that angle 3 and angle 4 are equal. That's what we just said. Bless you. But remember how angle 1 is complementary to angle 4. Angle 2 is complementary to angle 3. So angle 1 complements angle 4. Here's my angle 1, complements that. Angle 3 is complement to angle 2, or the other way around. Why can angle 1 and angle 2 be equal? Just for you guys to understand what we have that angle 1 plus angle 4 is equal to 90, my bad. Right, that complement. So we have that angle 1 plus angle 4 is equal to 90. We have that angle 2 plus angle 3 is equal to 90. That's what we have. But then angle 3 and angle 4 are equal. Right, we're saying that. Can we come and say angle 1 and angle 2 are also equal? And which rule is down? Not definition of bisect, because I'm not talking about anything about bisecting before that statement. But every time, like on my first statement, I could change the 4 for the 3. And why can I change the 2 for the 1? Which property allows me to change something for something else? Substitution. As a matter of fact, so we're going to have substitution. And I call this the beauty of geometry. Like geometry, the beauty of it is that if you guys go to another teacher might be able to find another rule, be like, oh yeah, you can use such and such rule for this one. Right? I recommend you guys, if you guys play sports or go to tutoring, or you guys just do know another math teacher, recommend you guys please do ask. Because that way they might help you. And like I said, the beauty of geometry, sometimes another rule might work. They might come over and come out with something called a transitive or something like that. We haven't used that rule yet, but they can come out with it and they will be correct. The beauty of it in geometry is that sometimes more than one rule do the same thing. And I say geometry is like you walking home. You can take one way to get home, or you can take another way and you get to the same point. That's the beauty of geometry. Alright, now looking at angle 1 and angle 2. So we said that earlier we said angle 3 is equal to angle 4, angle 1 is equal to angle 2, but so right now angle 1 and angle 2 are equal. Right? That's what statement 4 says. angle 1 and angle 2 are equal. But now, statement 5 says TR bisects angle STB. Which one? Okay, so we said angle 1 and angle 2 are equal, but then we're saying the segment TR bisects angle STB. What was it? Not quite. So we say angle 1 and angle 2 are equal. Angle 1 and angle 2 are equal. So you guys see my figure. And you see how TR is this line in between it, right? And so if they're saying if this is equal to this angle, then that segment cuts my angle in half. Okay, let me read the statement 5. TR bisects angle STB. What does bisect mean? Cut in half, so a line is going to create an angle in two different angles, and the two different angles are going to be equal. Okay, so we have angle 1 is equal to angle 2. Then we have TR bisects angle STB. As a matter of fact, it starts with the letter D. Definition of bisect. You notice statement 5 talks about bisecting. Statement 4 talks about what bisecting does. Every time we have a rule, and the rule does, that's the definition of such rule. And it doesn't matter if the definition comes after or before, as long as you have two statements, one of them is the rule, the other one's what the rule does, that's the definition of the rule. Alright, so that was easy. Let's take a look at this other one. Take a look at this other one. We have some given statements. That's some given statements, and we even have a picture right next to it, so we have an idea where things come from. So for my statement 1, J is a midpoint of HM. Why is that true? That was given. You guys want someone to write it over here. Statement 1 is true because it was given. Statement 2, why is statement 2 true? It was given. So matter of fact, most of the time, and I'm saying most of it, not always, most of the time, the statements that don't have an arrow before it, those are given. If it comes with an arrow before it, like looking at statement 3, comes with an arrow before it, that was not given. It comes from where the arrow starts. Alright, so looking at statement 3, that comes from statement 1. So J is a midpoint of HM. If you notice, HM is this segment. J is the midpoint. Now that way you guys see where my focus is. So J is the midpoint of HM. Why is statement 3 true? Definition of midpoint. Every time you see something mentioned, midpoint, like in statement 1, midpoint, and think about what is midpoint? The point in the middle of a segment. So there's a segment, the point in the middle, that means the two segments that it creates, the two little segments, HJ and JM, are equal. Alright, so we have that HJ and JM are equal. As a matter of fact, let me come over and mark them. HJ and JM are equal. I'll mark them the same. Earlier we said that GH and MO are equal. Right? We said that in statement 2. Notice I didn't mark all three the same way. See how GJ is this one. JO is this one. So for GJ, I have it as a segment GH plus HJ. Right? That's GJ. Yeah, you guys follow me? G, the following? Okay, the segment G and J, the segment G and J, so from G to J, is the segment GH plus HJ. You guys follow me? So from G to J, you go GH, right, that segment, plus HJ. You guys follow me now? Yeah. Alright, because I'm doing GJ, because that's Ford. Notice I also need JO. Yeah. So for Ford, I'm also going to think of JO is going to be the segment JM plus MO. You guys follow me? Alright. We said earlier that GH and MO are the same thing. GH and MO are the same thing. Right? We said that in statement 2. Another thing on statement 3, we said HJ and JM are equal. Right? That's what statement 3 said. Can we say those two are equal? What? Substitution. Nice. Every time substitution. Every time you change something for something else, there's substitution. Alright. Do me a favor, pick a hard one. Two on worksheet E. The one that's missing is this two? No, four on worksheet E. Two on worksheet E? Yeah. Easy. That one? Lockers or group? Yeah, you all combined pick one. Two. That one? This one? Yeah. This one? Israel. What? Alright. Let me, for the given, right, for the given we have three statements. Remember, on my reasons over here, usually the given statements don't have an arrow before it. Let me start with the second statement. BE is bisects DBC. I don't see that one in there. Alright, angle 1 comparing to angle C. Don't see that one in there. Okay, so let's take a look. Angle 1 is supplementary to angle 2. I'm going to skip 1 because I don't know what my statement is, so I'll come back to it later. So let me take a look at 2. Angle 1 is supplementary to angle 2. Here's angle 1, here's angle 2. I know supplementary means they add up to 180. How do you know that angle 1 and angle 2 add up to 180? It's a line made out of two angles. So that rule, it's a two-word rule, linear pair. Oh yeah, my bad. This is for 2, not for 1. So linear pair. Alright. Number 3, angle 5 and angle 6 are supplementary linear pairs. Okay, linear pair. Okay, so notice on statement 4, I need angle 2 is equal to angle 5. Angle 2 is here, angle 5 is here. Can I just come over and say for statement 1, let me fill that out. Angle 1 is congruent to angle 6. And why would that be true? Why can I write angle 1 is congruent to angle 6? Well, what's the 7? It's given. It's given. Alright. Alright, anyway, so given, statement 1 is given. Good. Right, that's why I wrote angle 1 is congruent to angle 6. It was given, the first statement given. Alright, so angle 1 is congruent to angle 6. We know, to begin with, from statement 2, we know that angle 1 plus angle 2 is 180, right?
Yes.
We know that angle 5 plus angle 6 is also 180, right? We know that angle 1 and angle 6 are equal. Why can I say 2 and 5 are also equal? Substitution. Alright, so 4 was easy. Number 5, notice how that statement doesn't have an arrow before it. So my reason for number 5 will be given, and I'm going to say number 6 will also be given. I'm going to write two statements, both of them are given. Which two statements am I missing in them? Alright, BE bisects angle DBC. And for 6, let me write EB bisects angle DEC. Alright, so just to have this clear, you guys see how DEC is this one, right? EB bisects that angle. So can I say angle 5 and angle 4 are the same thing? Yeah. Okay, so angle 5 and angle 4, let me put the little same marking. See how BE bisects the angle DBC? Can I say angle 2 and angle 3 are equal?
Yes.
Let me just mark them. I don't know if 2 and 3 are equal as 5 and 4, so for right now, let me mark them differently. But then, remember statement 4, angles 2 and angle 5 are equal? So all 4 angles are the same thing? Yeah. Okay. So if this angle, and this angle, and this angle, and this angle, they're all the same thing, why can I say DBC, which notice is the left angle, is congruent to angle DEC? Substitution. And the reason, because you guys are saying, well, how do we know DBC is equal to angle 2 plus angle 3, right? That's DBC. Angle DEC is equal to angle 5 plus angle 6. I know 2 and 5 are equal, 3 and 6 are equal, then DBC and DEC are equal. Substitution. I didn't write it down for 7. Substitution. There is a typo on you guys' proof. Let me find the typo here on this question. This one has a typo. This statement, it actually comes over here. MN is congruent to TV. Not there. And so there was a typo when I saw it today. I was like, oh, there is a typo on that one. MN TV goes on statement 3, not 4. So 4 is blank, fill in 4. For you to come up with 4, use statements 1 and 2. And then you guys know where to get statement 1.
Can you do the ones for the press?
Okay, like this one?
Yeah.
Alright. So we're going to say statement 1. Why is statement 1 true? Given. Why is statement 2 true? Why is statement 3 true? Alright, so three stuff. Good. Remember how bisect meant cut it into 2 parts, right? What does trisect mean? Cut it in 3 parts. So we have that from angle QYS, I'm going to say these 3 angles are equal, right? And if I look on the right side, I'm going to say these 3 angles are equal. Right? That's what statement 2 tells me. I know those 3 angles are equal. If this and this big angle, they're equal. That's what statement 3 tells me. Can I come and say a little angle from the black is equal to a little angle in red? Right, they're all equal? Why would that be true? Substitution. Substitution. But we're still missing one thing. Notice how statement 4 is black.
Yeah.
I'm going to fill that in with angle OYS is congruent to angle OSY. My last statement is always the proof statement. Remember, see how proof, I have a statement there? My proof statement is always my last statement. So, matter of fact, what we like, I don't remember how I did the proof for this year, but sometimes what I do like, when I give these in tests, I like to skip the last statement. When you guys have to fill in your blank, I like to skip the last statement, and I like to skip one given. I like to give you guys two easy questions. Right? The last statement is the proof statement, and make sure you reasons there's some that are given. Like I said, I like to do that. I like to skip the last statement and one of the given reasons and have you fill in the rest. I like to give you guys at least two free ones. All right. Any questions? Yes. Okay, no, maybe.
Maybe later.
Maybe later. We're all here. That's a good thing. Hold on just a second.